Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hopes you all are doing really great. So students, in this video we are going to solve very important question from the chapter Electrostatics. Okay, so let's go through the question. The question is 6 charges you can see in the order plus q, minus q, plus q, minus q, plus q and minus q are fixed at the corners of a hexagon of side D as shown in the figure. The work done in bringing a charge q0 to the center of the hexagon from infinity is how much here. Okay, so this is the situation. Here you can see I have taken the charge in a cyclic order, always cyclic order. See, if I start from here, okay, so see here q minus q, q minus q, q minus q, always in a cyclic order. Okay, and let's take here center is the C. Now this is the center of the hexagon is C, and here all the sides what is given here D. Sides of the hexagon what is given here D. So remember that here in case of a regular hexagon there will be 6 equilateral triangles. How many? There will be 6 equilateral triangles. That means I can write here all these sides will be also D only, is it? And now we have to calculate the work done. Okay, so to calculate the work done, first I will tell you one of the basic thing. The basic thing is that very easy. Let's take one electric field in this direction and one charge is there. Now this one charge q is there. Okay, so what will happen that here, let's take for example this charge q not this charge, it will experience force in the direction of electric field, because positive charge always experiences force in the direction of electric field. Okay, now if I want to move this charge opposite to the direction of electric field, I have to apply external force. Okay, and let's take now this charge is moving from, let's take initial point is I and final point is F, is it? So the charge is moving from I to F under the application of external force. Okay, so what will happen that here in this situation work will be done by this external force. Okay, so remember that here the concept is what, the potential difference between these 2 points, that means final minus initial, is equal to work done by external force to move the charge from I to F, that means initial to final point divided by q naught, is it? So we can tell potential difference between points F and I is defined as work done by external force to move unit test charge from I to F. That's why we are dividing with the q naught. Okay, so from here if I want to write here the work done by external force, okay, so what will happen that here I to F, it is given by q naught into Vf minus Vi, is it? This is the basic. This is what students say, this is the basic. This is the basic. Okay, see everything here, this is the basic. After that, if in case, remember that here, if in case kinetic energy is constant or delta k equal to 0, we can write here work done by the external force I to F will be equal to minus of work done by electrostatic force I to F. Okay, this is work done by external force, this is work done by the electrostatic force, but delta k should be 0. Okay, this is the basic. Kindly see very well, is it? Now students, if we talk about here our question, so in our question what is there, the charge particle is moving from the infinity to the center, is it? So in our question what is this, the initial point is the infinity and after that the final point is the center. Okay, so from here if I make the formula, what will be the formula here? Work done by the external force where to where, from infinity to the center, is given by charge q naught, and what we can write here, it will become here Vc minus V infinity. Now we are talking about now question. Okay, and remember that here always electric potential at the infinity is always 0, that is the reference. Okay, so what formula we can write here, the formula will become here W external where to where, infinity to C center, is given by q naught into Vc, is it? So this formula we have to use it here, is it? See, this is the formula here. Can you see very well the formula how we have make it, q naught into Vc, is it? Now after that here we'll come to our question. Now this is the question, and here if we calculate here Vc, what is the Vc? Vc means potential at point C due to all the charges. Here the shortcut is that if you will see that here all the charges, the sum of the charges are 0, and the observation point is equidistant from all the charges, then potential will be definitely 0. Okay, or if we want to calculate here potential formula, K into Q by R. What is K? 1 by 4 pi epsilon naught, not a dielectric constant. Okay, so see here, K into 1 by 1, let's take here charge, plus Q by D. Similarly other charge also, see, directly I am telling you, like it will be 0, but for just for your basic understanding I'm writing here, due to plus Q charge, minus Q charge, plus Q charge, similarly minus Q charge, again plus Q charge, is it, again minus Q charge, because charge and observation point distance is small fixed, is it. So what will happen that here in this situation, potential at point C will become what here, it will come here 0, is it. After that, if we'll use here the basic, what was the basic was there, work done by the external force, where to where we are moving, we are moving from infinity to C. What was that, Q naught Vc minus V infinity, correct. So this is the here Q naught, and Vc how much is coming here, 0, because all will cancel out, plus Q minus Q plus Q minus Q, all this potential will cancel out, 0, and this is also 0. So what answer will come here, 0 minus 0, 0 into Q naught, that means 0, is it. So can you see very well, question is very easy only. So which option is correct here, the correct option is here option B. Okay, so students, I hope so in this video of electrostatics we have learned the basics of potential difference very well. Keep studying, keep growing.